Hello students, welcome to online maths classroom. In this video, we will discuss about exercise 5.2, question number 1 to 10. This exercise is based upon the concepts of continuity and how to find the differentiability of the function. Okay, so let us start with it. First of all, we need to recapitulate the concepts of continuity and how it is connected with differentiability. So continuity at a point means a function fx is said to be continuous at x equal to a if the left hand limit at a and right hand limit at a, okay, both are equal and are also equal to the value of fx at x equal to e. Okay, that is the LHL, the RHL, both are equal, and also the value of the function at that point at which these limits are equal should also be equal to both these limits. Okay. And to evaluate the LHL of the function fx at x equal to 0, what do? We put x is equal to a minus h. And to check the right hand limit, we put x as a plus h. Continuity in an interval. You know that a function y is equal to fx is continuous in an open interval ab where a is less than b if and only if it is continuous at every point in the interval. Okay, it should be continuous at each point inside the interval. Okay, and for closed interval it should be continuous inside the interval also and at the endpoints also. Also some basic concepts that we have already learned, that are every identity function is continuous, constant function is continuous, polynomial function is continuous, a rational function is continuous provided it is defined, that means the denominator is not equal to 0. All trigonometric functions are continuous in their domains, like sine and cos are everywhere continuous, but if it comes for say tan like results, sine upon cos, so denominator should not be equal to 0. All these conditions we have discussed for all the trigonometric functions. What is the meaning of continuity? Continuity means that points simply joined. Okay, all the points means they are joined. Function is continuous means it has a draw which is smooth without any break. Okay, smoothly joined. Okay, they are joined means there is no break. Without break everything is going. Okay, I don't have to lift my pen before making this point meet. Okay, then we say that the curve is continuous. Differentiable means that no doubt this curve is continuous. Okay, this is continuous. Okay, but differentiability means that at a point it should be smoothly joined. Okay, it should be smoothly joined. So if I say somewhere here, no doubt it is smoothly joined. Somewhere here it is also smoothly joined. But if I talk about here, you can feel that there is a bump. That means it is not smoothly joined. Okay, the behavior has altogether changed abruptly. Okay, that is at the point the gradient on the left hand side has to be equal to the gradient on the right hand side. Gradient is your derivative. Okay, so that means say if I'm checking the differentiability at this point, see my pointer, that means to a very point up and down the value of the derivative should be same. This is what I mean to say by your differentiability. This we will check while finding the left hand derivative and right hand derivative. Okay, so function will be differentiable at a point if, like limits, its left hand derivative is equal to right hand derivative. Okay, so you can see that if this parabola is there, okay, you can certainly would not accept this to be a smooth joint. No, you know that this is not a smooth joint, so I can't say that the function is differentiable here. Now, however, suppose alongside this figure there is a line y is equal to 4x minus 5. Okay, now let us substitute x is equal to 2 in some line, y is equal to x square minus 1. What is the value? You will get 4 minus 1, that is 3. And x is equal to 2 in this line. Okay, what you will get? It is at 3. So that means there are two different curves. You know that the two will join at the point 2, 3. Okay, as both the curves are continuous, as you will keep on filling the values, you will have you will keep on getting the values of y if you keep on changing x. Okay, now by finding the ordinary derivative of each function, what do we get? Say gradient of this parabola. This is a parabola. Okay, So gradient means you must be aware about the derivatives, how to take, dy by dx is 2x. Okay. So the gradient, when the value of this is gradient, derivative is gradient. Okay. So gradient at x is equal to 2 means the value of this derivative at x equal to 2, say it is 2 into 2, that is 4. For the second one also, dy by dx here also it is 4. And for x equal to 2, it is coming out to be 4 as there is no x. So we find that left hand derivative is equal to right hand derivative. Okay. What does this means? As a function, say if it is defined like this, it will be differentiable as the left hand derivative equal to right hand derivative. And in this case, not like this case, in this case the graph would be like this. It will be having a smooth join. Okay, it will be having a smooth join here, not like this, an abrupt join. Okay, so this is what we mean to say by your differentiability. Okay, now what is how to check and what is the relationship between differentiability and continuity? So students, please make it clear that you know what is continuity means, that when you will plot the graph will be without any break. Okay, without any break, and you don't need to pick up the pencil for joining it. Okay, so this is what we mean to say by you keep on putting the values and you will keep on getting the values. Okay, so this is what we mean to say continuity. Whether it is increasing, decreasing, means it should be continuous. Okay, and what is the meaning of differentiability? Now see, let us see, check from this graph. Okay, curve, say these are the 2 points, this is your C. We are checking the differentiability, and this is the point C. Okay, this is the point X, and C, at C this Y value is your f of C, and at X the Y value is your fx. Okay, okay, so what is this difference? This difference is your x minus C, this x minus C, that is x minus C. Okay, now you know how to find the slope. See this triangle. Okay, how to find the slope? Slope is y2 minus y1 upon x2 minus x1. Now see from here, what is y2 minus y1? It is fx minus fc upon x2 minus x1 is x minus c. Okay, and the very small rate of change between them. Okay, very small. For h approaches to 0, for x approaches to c, or h approaches to 0, for a very small change, this value which you will get of the function here will be called the derivative of the function at that point. Okay, because we have done the first derivative test in your last class 11th also, and you know how to check the derivative of f at c, which we called as the first principle. Okay, so f dash c is your limit x approaches to c, f of x. Okay, this is actually y2 minus y1 divided by x2 minus x1. And you know how to evaluate for evaluating right hand derivative and left hand derivative. I will put as for left hand derivative, I'll put at x as c minus h, and for right hand derivative, I'll put as x as c plus h. And as we go for the continuity checking, we will go for the checking of the differentiability. So this has already been studied by you as like your first principle, okay, in class 11. Okay, now see, this is an example here. You find that, say there is a function minus x plus 1. Okay, this is a problem where you are having a graph here. See, now you can see it is not differentiable at 1. Okay, not differentiable at 1. Why not differentiable at 1? See, this is not a smooth join. Okay, this is like a sharp join. Okay, so the left hand derivative definitely will not be going to be equal to a right hand derivative. So you will study that continuity is something you can draw without picking up the pencil, and differentiability means a smooth rate of change. Okay, a rate of change with a means joining alongside with a smooth curve. Okay, so mathematically a function is differentiable at a point A in its domain if limit x approaches to A, fx minus fa upon x minus a, means the same definition, your first principle, exists finitely, and when it happens if and only if the left hand derivative, limit x approaches to A from negative side, fx minus fa upon x minus a, this is equal to limit x approaches to A from positive side, fx minus fa upon x minus a. That is LHD is equal to RHD. LHD at that point is equal to right hand derivative. Then we say function is differentiable. Okay. So it is just like how to check the LHL and RHL in same way, but just you have to keep in mind this principle. And you are familiar with algebra of continuous function also, that if f and g are two real valued function which are continuous at real number c, then their sum, their difference, their product, okay, their scalar multiple means c times f, where c is any constant, will also be continuous, and the ratio f upon g is also continuous at x equal to c, provided this g of c is not equal to 0. Okay, so all these conditions you have studied. Okay, so if, and also you know, if f is continuous, then mod of f is also continuous. These are some standard results of limits which you have studied in your class 11. Okay, when you studied the supplementary portion, there you have studied few results which we will be using while solving this year further topics. So let us recapitulate them once again. What was it? Limit x approaches to a, xn minus an upon x minus a is nan minus 1. You know, we have proved it, like put x is equal to a plus h like this, and then open like binomial theorem, and this can be solved to get nan minus 1. Okay, second result was limit x approaches to 0, sin x upon x is 1. And limit x approaches to 0, tan x upon x is 1. Limit x approaches to 0, ex minus 1 upon x is 1. Limit x approaches to infinity, 1 upon x raised to power p. Now you know 1 upon infinity raised to power p means it is infinity. Okay, so 1 upon infinity is 0. Then this result, limit x approaches to 0, log 1 plus x upon x is 1. Limit x approaches to 0, ax minus 1 upon x, where a is a real number, is equal to log to the base e of a. Limit x approaches to 0, sin inverse x upon x is 1. Limit x approaches to 0, 1 plus x raised to power 1 by x is e. Limit x approaches to infinity, sin x upon x is 0. Okay. Then limit x approaches to infinity, 1 plus 1 upon x raised to power x is e. And limit x approaches to infinity, sin x is equal to limit x approaches to infinity cos x. Okay, because why they are equal? Because you know that sine, you can't say that limit x approaches to infinity sin x is infinity. Okay, you know that sine and cos are oscillating functions which have their values lying between minus 1 and 1. That's why the values cannot go beyond minus 1 and 1. So both of them will be having any larger value you put, it will always be having the greatest value as 1 and the smallest as minus 1. Okay, so remember these results. Now differentiability, let us remind before starting. A function fx is said to be differentiable at x equal to a if LHD, left hand derivative, at x equal to a is equal to right hand derivative at x equal to a. So how to calculate c, how to check it? Now we have not taken that x approaches to a, like it is simply like, say we put as for right hand derivative a plus h and for left hand a minus h. In that way we have done. Okay, so limit h approaches to 0, f of a plus h minus f of a upon h, and left hand will be like limit h approaches to 0, f of a minus h minus f of a upon minus h. How? Because we have put your x as at 0 we are checking, so it has 0 plus h and 0 minus h, or a plus h and a minus h. Okay, so this is the definition. So this will automatically be framed, don't worry about it. Okay, so every differentiable function is continuous, mind it. If a function is continuous, then only we can check the differentiability or rate of change. You very well know that the derivative of a constant function is 0 because there is no rate of change. Okay, so function is continuous, then only it is. If it is differentiable, then it must be continuous. But every continuous function need not be differentiable. You know the constant function, it will be having a, say, straight line graph. Okay, it can keep on moving like this, but as there is no rate of change, so the derivative is 0. Okay, so what is the differentiation? It is the process of finding a derivative of a function is called the differentiation. It is also called as gradient. Okay, so let us start. What were the rules of differentiation? Let us remind once again, sum and difference rule, that is your, if y is fx plus gx or fx minus gx, then how can we differentiate? We will differentiate it independently. That is dy by dx is equal to ddx of fx plus or minus howsoever it is ddx of gx. Product rule says, your UV rule or product rule says, if it is product of two function, then first function into derivative of second plus second, okay, plus second into derivative of first, or second into howsoever you can go, okay. So it is like, say, first function into derivative of second plus second into derivative of first. What was quotient rule for fx upon gx? It is denominator square, okay, and in the numerator, like denominator times ddx of numerator minus numerator times ddx of denominator, okay. And there was a chain rule also. Y is equal to f of u means your two function, say y is expressed as f of u and u is expressed as f of x. Then how we find the derivative of dy upon dx? That firstly I'll differentiate it dy upon du, from here du upon dx, okay, and then to get dy upon dx I need to multiply dy by du into du upon dx, and that way I will get the value of dy by dx, okay. But it will happen only when this dy upon du and du by dx both are existing. Logarithmic differentiation, okay, there is a direct formula also, and there is some other formula where what we do, say like this is a in this kind of differentiation which will be solving in your 5.3 exercise, y is equal to fx raised to power gx, okay, function raised to power another function, okay. So this type of differentiation to be carried out taking log both sides. So we will do it by log y is equal to log m raised to power n is your n log m, like gx log fx, okay. There is one way this, and by using the chain rule it can be differentiated to get this kind of result, okay. Parametric form you will be doing in the next exercise, and parametric form is just like we did chain rule. Say x and y both are function of, say, t. Then to get dy by dx, what I need to do is I'll differentiate like dy upon dt, dx upon dt, and by dividing both I'll get dy by dx. And second order derivative means that I have to redifferentiate, okay. Say this is dy by dx, so again I will take its ddx to get, say, ddx of dy by dx means d square y divided by dx square. It is not dx whole square, it is dx square, okay. And some standard results you must be having the knowledge of. The derivative of sine is cos, cos is minus sine, tan secant square x, we all did it in class 11th. Secant x derivative is secant x tan x, cosecant x is minus cosecant x cot x, cot x is minus cosecant square x, sine inverse x is 1 upon under root 1 minus x square, cos inverse x derivative is minus 1 upon under root 1 minus x square, tan inverse x derivative is 1 upon 1 plus x square, secant inverse x derivative is 1 upon x into root x square minus 1. Cosecant inverse x derivative is minus 1 upon x root x square minus 1. Cot inverse x is minus 1 upon 1 plus x square. ddx, this is power rule. X raised to power n is nxn minus 1. Derivative of ex is ex. Derivative of ax is ax log to the base e of a, where a is some positive number, okay. ddx of constant is 0 and ddx of log to the base e of x is 1 upon x, where x should be greater than 0, okay. So as we did that, this was proved last year. We proved it using first principle. This year we will be proving them, all of this inverse trigonometric function, using your first principle also, okay. We will be using these results to prove these results, okay. We will go for the proof of it also, but you need to remember them, okay. So question number 1, it is very simple. Differentiate the function with respect to x, okay. So this is the function sine of x square plus 5. So this is your y or fx, whatever you want to write. So how should I go for its differentiation? It is ddx of sine of x square plus 5. So remember, we should go for the chain rule. First term will be of this outer sign. So it will be like cos of x square plus 5. And then what is inside? ddx of x square plus 5. See from here. Firstly, I'll go for this derivative of this sign. So it will be cos of x square plus 5 into ddx of this x square plus 5. Okay. So what is ddx of x square? It is 2x. Okay. 2x, 2 minus 1, that is 2x. And the constant derivative is 0. Okay. So it becomes like product. It turns out to be 2 times x cos of x square plus 5. Okay. All the formulas are written here. Now cos of sin x, again one and the same thing. I'll go for the outer cos derivative first. So it is like sin x, sine of sin x, okay, because cos derivative is your minus sign, okay. So I'll getting it as minus sine of sin x, okay, minus sine of, I'll just firstly go for this differentiation of this cos. So it is minus sine of sin x into ddx of this sin x. So what is ddx of sin x is cos x, okay. This is dash means the derivative, okay. So this is outer one is minus sine of sin x into ddx of sin x is your cos x. So the answer is minus cos x sine of sin x, okay. This one is sine of ax plus b. How should we go? Firstly, it will be cos of ax plus b, see, into ddx of ax plus b, ddx of ax plus b, okay. Now a is a constant, it will come outside, and what is ddx of x? X is 1, okay. ddx of x is 1, so it will be like a, because a is outside, and b is a constant, no x is there, so derivative is 0, okay. So the answer is a cos ax plus b. Number 4 is differentiate the function with respect to x secant tan root x. Now remember students, when I have to differentiate such function, chain rule is applied. I will firstly go for the differentiation of this secant, then for this tan, and then for this root, okay. But you have to keep everything all together, okay. So firstly, let us understand what were the derivative of secant x, what was the derivative of tan, and then what is the derivative of root x. So firstly, you should recapitulate, because you need not do it that way, but I'm just reminding you how the derivative of secant x is taken first. So secant x is your 1 upon cos. You can go for this your quotient rule, okay, that way. Otherwise, if you remember, you know the derivative of secant x is secant x tan x. So what will be the derivative of it? It will be secant tan root x into tan root x. Secant x is, say this is complete x. Secant x is secant x tan x. The derivative will be secant tan root x into tan root x into ddx of this tan root x. This tan root x dash means it is derivative here. Okay. So this first part is finished. Now come here, concentrate here. It will keep on coming like this. So now firstly I should go for the derivative of tan. What is the derivative of tan? Tan is secant square. So it will be secant square root x into ddx of this root x. This is how chain rule is applied. Firstly it will be secant derivative is secant tan root x into tan root x. Then ddx of tan root x is secant square root x, and now the term of derivative of root x. Now the derivative of root x is your half power rule, half x raised to power half minus 1. And when you will solve, if you remember from the previous year, you know it is 1 upon 2 root x. I told you that it can be taken like this, okay. So when you will combine them all together, so it will be your secant tan root x, okay, and then your secant square root x, and then it is by 2 root x, okay. So secant tan root x, okay, and then tan root x and secant square root x divided by this complete 2 root x is the required answer. Number 5 is your, here you have to use the quotient rule, you know. So it will be like, we'll go quickly. How can we go for it? Either you know the derivative of it, okay. So the derivative of top will be like how? It will be cos of ax plus b into ddx, which comes from inside will be just a. So you know it is a cos ax plus b. So it is very well explained here how we have what will be the derivative of the numerator, and the denominator will be your, you know what is the derivative of cos is minus sine. So it will be minus sine cx plus d into ddx of cx plus d is your c. So when you will solve, it will be minus c sine cx plus b. Okay. So this is just for elaboration purpose, that how derivatives can be found, but we need to, for calculation, we need to apply quotient. Now dy by dx. Okay. So using quotient rule, you know how to apply the quotient rule. Dy by dx is denominator square, okay, denominator times ddx of numerator minus numerator times ddx of denominator, okay. We dash and u dash means the ddx of your u and ddx of v. Okay, so when you will apply, the question can be solved simply. Okay, just leave it up to here. There is no need to solve it further. Okay, so I think this kind of question has been done in class 11th also, so it will be simple for you. Number 6 is your cos x cube into sine square x5. Now again this is a question of say chain rule. So see how we are going to do. I can use product rule, like I will take this cos x cube as u and this as v. Then I can go for chain rule. But first of all, let us understand what will be the derivative of this cos x cube. So derivative of, you need not do it. Okay, it is just for the explanation purpose. So the derivative of cos x cube will be firstly like minus sine x cube into ddx of x cube is 3x square. So it is minus 3x square sine x cube. For this part, firstly, you know, sine square x5. So firstly, I need to apply the power rule. So it will be 2 sine x5 into now the derivative like this. See, 2 sine x5. Now the derivative of sine x5. Now leave the power behind. Okay. So derivative of sine is cos x5. And then the derivative of x5, that is your 5x raised to power 4. See, how should we go? Firstly, the power 2 sine x5, okay, into ddx of now sine x5. See, ddx of sine x5. Sine x5 will be cos x5. And now the derivative of x5, that is 5x4. So this is how we get the derivative. Now we can apply the power rule by taking it as u and it as v. So like it is u ddx of v plus v ddx of u. Okay, so every derivative is here, and by opening it you can get this result. Okay, so question number 7 of your NCERT is differentiate the function with respect to x 2 times root cot x square. Okay, so let y is 2 times root cot x square. So you know how chain rule will be applied. You firstly need to this differentiate the power, then the function cot x square inside, and then x square inside. Okay, so let us start. Okay, so dy by dx is your derivative of this dash, means we are going to differentiate it. So it will be like 2 times ddx of this constant is outside, ddx of this under root of cot x square. Okay, now what is the derivative of root x? You well remember, it is 1 upon 2 times root x. Okay, so it is 1 upon 2 times the whatever is inside this root. Okay, and then you need to do the ddx of what was inside the square. Okay, that is cot of x square, derivative of this. Okay, I hope you remember how to take the derivative of square root. Square root is root x's derivative is 1 upon 2 root x. So anything inside square root will be differentiated like first 1 upon 2 times this root x into ddx of what was inside that root. Okay, so the derivative of cot x square is your minus cosecant x square, and the derivative of then x square. Okay, so x square dash. Okay, what is the derivative of x square is 2x. Okay, so simply it can be arranged and written as minus 2x cosecant x square over root cot x square. Then is differentiate the derivative of it. So it's again very simple. Now we have done the previous question, so this one is simpler as compared to it. So how should we go? ddx of this will be, say, firstly minus sine root x and then ddx of root x, and you know what is the derivative of root x is 1 upon 2 root x. So it is minus sine root x divided by 2 root. Number 9 is your proof the function is not differentiable. Now this is the first question which came for differentiability. You know, we have to check the left hand derivative and right hand derivative. So fx is your mod of x minus 1. X belongs to R is not differentiable at x equal to 1. Okay. So firstly, I just need to define, you know, mod how behaves, that this will be plus x minus 1 if x minus 1 is greater than equal to 0, and minus times if it is less than 0. That is, if x is greater than equal to 1 and x is less than 1, this is the defining. Now I have to check the differentiability. So left hand derivative is like, okay, limit h approaches to 0. Okay, f of, say, you know, it is like, say, if I'm checking it at 1, so it will be like limit x approaches to 1, f of x minus f of 1 divided by x minus 1. Okay, so for, you know, for LHD what we need to do is I just need to put x as 1 minus h. So it will be like f of say 1 minus h minus f of 1 divided by h. Okay, so to the balance the negative sign, what we have done is we have shifted the numerator like f of 1 minus f of 1 minus h. Okay, if you want to retain the negative sign in the denominator, then it is okay, like you can go for this. So this is the reason why we took this f of 1 first and then f of 1 minus h here. Okay, so where should we put 1? Here. So 1 minus 1 mod will be 0, and next will be your say 1 minus h minus 1. Okay, outside the mod. So outside the mod, it will be coming out as your minus h upon h, that is minus 1. Okay, and the right hand derivative similarly, when you will solve it like this, okay, as you can use this defining as it is given here. For right hand derivative this one, for left hand derivative this one. Okay, so it will be turning out as 1, and you find that LHD is not equal to RHD. That means function is not differentiable at 1. Okay, and to check the differentiability of this greatest integer function between 0 to 3 is not differentiable at x equal to 1 and x equal to 2. Okay, so at 1, how will we check? This is the left hand derivative. Again, limit h approaches to 0, f of x minus h divided by h. Okay, why do we take it for left hand derivative? As you know that when I'll be taking like this, say put 1 minus h, so the denominator will be like, for x minus 1 it will be like 1 minus h minus 1, that is minus h. So to balance that denominator sign, we take it as like this. We can take it as, okay, f of 1 minus f of 1 minus h. Okay, so integer function 1 minus integer function 1 minus h. So what is integer function 1? 1 is itself integer, so it is 1. And for 1 minus h, you know, for c minus h it will be c minus 1, that is 1 minus 1, that is 0. So it is not defined. For right hand derivative, it is 1 plus h, you know, it is as 1 itself. Okay, and this is 1, and it also turns out to be 0. So LHD is not equal to RHD. Function is not differentiable at x equal to 1. Okay. Okay, and say for if we want to check the differentiability for 2, then you know that for 2 it will be like, again for LHD, you know that if I go for f of 2 minus h minus f of 2, so denominator will be having minus h. So to balance it, it can be written like this. Okay, so this is your integer function 2 minus this integer function 2 minus h divided by h. Okay, and for right, again it is f of 2 plus h minus f of 2 by h. So it is integer function 2 plus h minus integer function 2. Okay, and it is limit h approaches to 0. Okay, you know, remember the integer function. How does this integer function behaves? Okay, you know, for c minus h it was c minus 1, that is 2 minus 1 is 1, and for c plus h it was c, so that is 2. So it will be 1 by h, okay, which is not defined, and it will be 0 by h, which is 0. So again LHD is not equal to RHD. The function is not differentiable at x equal to. So this was all regarding your exercise 5.2. Okay, please go through each and every concept that has been taught well. Okay, the concept of differentiability is a bit new, but as you have already done the concept of limits, okay, so it will not be difficult for you to check the left hand derivative and a right hand derivative. Okay, so practice the question of differentiability so that you are able to focus on such questions where you have to check the differentiability of the questions. Okay, and mind it, make it very clear that if a function is not continuous, it is not going to be differentiable. Okay, so it is suggested that firstly you need to know whether the function is continuous or not. If it is continuous, then only it will be differentiable. Okay, and if it is given differentiable, then it is already continuous. Okay, I hope everything is clear.